Hey everyone, let's do a partial fractions problem similar to ones we've done in class, but not exactly the same. Looks like we've got a degree 4 polynomial on the denominator. So we're going to write this as split into partial fractions, as we always do. Just want to be a little bit careful about how we split it up, because we're actually going to have three partial fractions, right? Can you see what they are? A over x minus 1 plus b over the quantity x minus 1 squared plus cx plus d over x squared plus 1. All right, remember we need a term for both the degree 1 term and for the constant. So writing this all over a common denominator and then ignoring the denominator as we always do, we have a times x minus 1 times x squared plus 1 plus b times x squared plus 1 plus cx plus d times x minus 1 quantity squared. Looks like that's all going to equal x squared minus 2x minus 1. And I guess if we, well, actually, I guess we can stop right there, right? And we can say, well, there might be a value of x we can plug in, right, to solve for something, right? Let x equals 1. And so we have that b times 1 squared plus 1. Maybe I should say we have 0 plus b times 1 squared plus 1 plus 0 equals 1 squared minus 2 times 1 minus 1. Make sure to plug in 1 for x on the other side too, right? And so that means that 2b equals, what was that, negative 2? So I'm getting that b equals negative 1. All right, just double check that. Looks good. Okay. So we have one variable that we solved for. Just highlight it to remember, okay? Now at this point, I think what we need to do is the standard, FOIL it all out, make it, you know, combine like terms, right? The stuff that we've been doing. Now, right, this will be a little bit of work, right? We're going to have ax cubed minus ax squared plus ax minus a. I think that's what we get, right? X cubed minus x squared plus x minus 1, yep. Plus bx squared plus b plus, oof. I don't think I can do this one in my head. Right? This one will go to a sidebar for this one, right? It's going to be cx plus d times x squared minus 2x plus 1. A little annoying to multiply out, but I think we'll be okay. Cx cubed minus 2cx squared plus cx. And then it's going to be plus dx squared minus 2dx plus d. There we go. Okay. Right, and then I guess all of this equals x squared minus 2x minus 1. All right, and then this implies, right, if we just combine the like terms, right, what do we have for cubed, right? A plus c x cubed plus, and then what are we going to have here for x squared? Negative a plus b, and I think it's plus d. And then what are we going to have for x? A, c, and negative 2d. And then I guess we have minus a plus b plus d. Okay, I think I accounted for every term. Let's just quickly check. A and C, x cubed, negative a, b, and dx squared, a, c, negative 2dx, negative a, positive b, positive d is a constant. Yep. Oh, good. And then this, of course, equals x squared minus 2x minus 1. Well, then, okay. If we know that a plus c equals 0, but of course that also equals... Oh, no, sorry, never mind. We don't quite know about a yet. We actually know about b. So where can we go for something with b? Should have a little bit of an issue right here. So something a little bit unfamiliar, right? We got a little bit of a concern right here, right? Because we plug in 1 for b, or negative 1 for b. Not actually going to give us anything. So this might be a third technique that we need to worry about. Well, let's take a look. Yeah, it looks like there's no way around this. I think we're going to need to do a system of equations. All right, so what we're going to do here, new technique right here, we're going to examine these two guys. Right, note that they're, well, actually, in this case, they appear to be the same thing, right? So I guess whatever one is, the other is going to be as well. So, very interesting. Let's see how we might be able to reason with this one. I guess what we could say, maybe if we're clever, maybe that won't even work. One thing we can say is, if we take a look at this and this, we could say, note that a plus c equals 0, and a plus c minus 2d equals negative 2. But, right, that equals 0 minus 2d. You see what we did right there? We replaced a plus c with 0. So it looks like d equals negative 1. Nope, positive 1. Right? If minus 2d equals negative 2, then d equals positive 1. Alright, so we have that. Is that going to give us anything? I still think we might have a little bit of an issue here. Right? Because we have, well, we can make this work, but it's going to require a system of equations, okay? Now, let's note that a plus c equals 0, and also note that negative a plus b plus d is going to equal 1. Okay. Well, if we know that d equals 1, I guess we have negative a plus b plus d equals 1, or plus 1 equals 1. So I guess that means that negative a plus b equals 0. So on the one hand, we have a equals negative c and a equals b. Oh wait, and we already know what b is. Right? Never mind. So what we can actually do with this, sorry, let me erase this. We already knew what b was, right? So we have that negative a plus b plus d. Well, that's going to equal negative a minus 1 plus 1, which is negative a, equals 1x squared. So I guess a equals negative 1. And now, last but not least, since a plus c equals negative 1 plus c, which equals 0, c equals 1. Whew. A little bit of work right there. little bit of work, a little bit different, right? But we were able to, right? We needed a little bit of trickery to get D. Well, we were able to get it. All right. Let's go back to our original guy right over here, right? We've got, woof. A over x minus 1, well, that's going to be negative 1 over x minus 1 plus b also minus 1 over x minus 1 squared. Cx plus d over that plus x plus 1 over x squared plus 1 dx. And this is actually not all that bad to integrate since we've seen it a million times now, right? Negative L in the absolute value of x minus 1. This is going to be minus 1 over x minus 1 plus 1/2 ln this guy, right? You do the u substitution plus arctan of x plus c, I'll call it c2. Whew. All right. That's how you do it.